Hi, Mr. Conklin here, and in this video we're going to talk about inequalities. And in this video specifically, we're going to be looking at what an inequality is, what it represents, and also how to identify if a given value is a solution for an inequality. So first, let's begin by looking at some of the inequality symbols. Some of these you definitely should recognize if you don't recognize all of them already. The first two is less than or is greater than are commonly associated with an alligator. All right, and you might have learned about these back in second grade that the alligator always goes for the bigger number, and someone also mentioned one point to me that you can think of the smaller side as a bird's beak, and that the bird beak always goes for the smaller number. So it's very important that when you're setting up your inequalities that you're using the correct symbol. We also have two other inequalities, is less than or equal to, and is greater than or equal to. Now, before we look at some of the problems that we're going to be using these inequalities in, let's just kind of make a connection to equations and how equations and inequalities are somewhat similar. So with an equation, you learned when we talked about the balance that one side of the balance, let's say I had 3 marbles, was equal to the other side of the balance. And an equation was true if both the left side and the right side of the equation had the same amount. So when we were solving for equations and trying to find an unknown value, we could think of it like this. If I had 4 marbles on the left side of a balance and I had an unknown amount of marbles in a box on the other side, and we asked ourselves how many marbles would be on the right side of the equation, well, there's only one possibility, because in order for the balance to be balanced and equal, there has to be 4 marbles on this side as well. Inequalities are a little bit different. With inequalities, we have a balance that is not balanced. Or in some cases, as in these two here, we might have a scale that could be balanced. So for example, let's say that I had a balance that looked somewhat like this, where the left side of the balance was slightly heavier than the right side. Now, if I were to ask myself, if I were to put on this side 3 marbles, let's make it a little bit more, let's make it 6. And I were to ask myself, how many marbles could be on this side of the balance in order for this balance to be true? Well, there are a number of possibilities. I could have 1 marble on this side. I could have 2 marbles. I could have 3 marbles. I could have 4 marbles. I could have 5 marbles. But I could not have 6 marbles, because in that case, this balance would then be equal. So when we're talking about inequalities, the biggest difference between an equation and an inequality is that equations only have one solution, whereas an inequality can have many solutions. So when we're thinking about inequalities, we're now looking at values that could satisfy the inequality, but thinking about the fact that there could be more than one inequality, or more than one value in the inequality. And as we explore this topic a little bit further, you'll see why inequalities are more appropriate for some situations compared to an equation. So let's look at some problems that you're going to see on your assignment. It says, of the numbers 8, 9, or 10, which is a solution of the inequality n minus 3 is greater than 6? So what this is saying is that the left side of the inequality, the n minus 3, has to be greater than 6. So we're going to take the solutions or the possible solutions that are up top, 8, 9, and 10, and we're going to substitute those in to the inequality and see if it's true. So first, I'm going to start with 8. Well, if I substitute 8 in for n, I get 8 minus 3 is greater than 6. Well, 8 minus 3 is 5, and 5 is not greater than 6. So 5 is not a solution, or excuse me, so 8 is not a solution. In our next number, we could have 9. 9 minus 3 is greater than 6. Well, 9 minus 3 is 6, and 6 is not greater than 6. So in this case, 9 is also not a solution. If we try 10, 10 minus 3 is greater than 6. 10 minus 3 is 7, and 7 is greater than 6. So 10 is a solution. So the only value in the list above, 8, 9, and 10, that would be a solution for this inequality would be 10. Now we're going to look at some questions where they're asking, is the given value a solution to the inequality? So on the left side of the inequality, I have x minus 5, and the x minus 5 has to be less than 5. So they're saying, in this situation, if I were to substitute 15 in for x, would 15 minus 5 be less than 5? Well, let's substitute and find out. 15 minus 5 is equal to 10, and 10 is not less than 5. So in this case, I would say, no, 15 is not a solution. On the next one, we have 32 is greater than or equal to 8 times n. So what this means is that if the 8 times n is less than 32, or if it's equal to 32, then the value is a solution. So we're going to set this up. 32 has to be greater than the product of 8 times 3. Well, if I simplify this, 32 is greater than or equal to 8 times 3, which is 24. And is that true? Yeah, 32 is greater than 24. It does not have to, and it cannot satisfy both greater than and equal to. It's either one or the other, because a number either is equal to a number or it's greater than or less than a number. So in this case, I would say yes, 3 is a solution. So there you have some examples of inequalities, and the key thing to remember is making sure that your inequality symbol is facing the appropriate way. Remember that the open side always faces the larger number in the inequality statement, and the smaller side, or what's sometimes considered the bird's beak, faces the smaller number.